Yeah, I'm recording. Okay, Isabella, I saw your hand up.
Okay, so osmoregulation is a process whereby an organism, like for example, the paramecium is able to create a balance between water and this internal body. So that means the organism is regulating the amount of water it needs in its body, by making sure that the excessive ones are outside to ensure that not too much of water has entered into the system and the required nutrients is being absorbed.
All right, all right. That's fine. That's fine. That's fine. Okay. So as living organisms, right? We are supposed to maintain a balance, or even in the world that we live in, there's supposed to be a balance. So that's the reason we have some checks and balances put in place to ensure this. If not, there will be chaos, right? And you've learned about hypotonic, hypertonic, isotonic, etc. You've learned about all that. I'm not really going to go through it again. But here lies the case that you have excess water entering into the paramecium. If this continues frequently or without being controlled, what will happen is that the paramecium will just burst. It will burst open because now it has too much water. You've learned this from placing organisms in hypotonic solutions, right? They absorb water till the best, especially like, for example, red blood cells. I know in JHS used that for your experiments where you have to drop some amount of blood in solution and then for some time you realize the red blood cells will swell and burst up. So if this doesn't occur, what will happen is that the paramecium will just burst open, and that will be the end of life of the paramecium. So it needs some balances. It needs something to check that. And that is what the contractile vacuoles do. Do we get it? So now for excretion osmoregulation. Osmoregulation in biology is the maintenance of the internal balance of an organism between water and its dissolved ions, etc., regardless of environmental conditions. So what does this mean? The paramecium is an organism. It keeps moving, right? It's going into different areas or different environments. If it gets to these environments, it's isotonic with it. It gets here, it's hypertonic. It gets there, it's hypotonic. So it needs some checks and balances. So how does this happen? Happens through the contractile vacuole. If there's excess water, what happens? These vacuoles are storage mechanisms within the single-celled organism, right? So what happens is that the contractile vacuole would keep filling up with water, And mind you, this water will also have certain dissolved ions, which maybe need to go out of the cell, right? So the contractile vacuoles will keep swelling up and keep swelling up. So at a point in time when it is full to capacity, it goes to fuse with the pellicle, let me say, or the outer covering of the paramecium, what we will call the plasma membrane. It goes to fuse with it such that the excess water is expelled out of the cell, right? So you have the excess water which would have certain dissolved ions out. And then because it is single-celled, though it has a protective membrane, which is, we are calling the pellicle, that membrane is protective enough, but because it's single-celled, we assume it's quite thin. So what happens is that for excretion, it needs no serious or complex mechanisms like in multicellular organisms like humans. You see, in humans, we have your kidney leading to your bladder and then your excretory system, blah, blah, blah. The paramecium doesn't need that because it's single cell. So what happens is that the excretion takes place via the diffusion. So whatever it needs to go in diffuses through the membrane inside. Whatever needs to go out diffuses out, such as oxygen and carbon dioxide. This is how the paramecium lives. So O2 would go in, simple diffusion, dissolve, or it can even get dissolved in the water that enters through the oral groove. But most of the time, it's through simple diffusion. Diffuses through the membrane and then the CO2 diffuses out. Please, do we all get it? If you have any questions, you can raise your hand.